I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand and do a little bit of chemistry in your everyday life.
Ayo, I love doing chemistry in my everyday life.
You get to do it every day, don't you? Pretty much, in some formats, surely.
I get to think about it every day. I don't get to do it in the lab every day anymore, which, especially because of coronavirus, COVID-19, I would not probably be in the lab anyway. So
Right.
It's a necessary part of life to grow up and leave home in your lab.
Grow up and leave the lab, yeah.
Today we're going to be talking through an experiment, just like we did on our last Chemistry for Your Life, Chemistry at Home bonus episode. So, Jam, today I made you do an experiment and I told you absolutely nothing except the mechanics of how to do it.
Yeah.
Do you want to talk through what you did?
Yes. So I was instructed to grab a coffee filter, which thankfully I have many of, all shapes and sizes and kinds, and a marker, not a Sharpie, but like a marker, like a Crayola or other brand kind of fun marker.
Mm-hmm.
And a glass of water. And I was instructed to draw a line with the marker on the coffee filter and then dip the coffee filter into the water just to where the line didn't quite get in the water, where the part of the coffee filter that was in the water does not have any marker on it, and just hold it there for a while. And so I did that.
And what happened? Can you describe in your own words what happened there?
The coffee filter being dry, immediately started soaking up the water. And the water just crawled up through the coffee filter, even though I was holding it, vertically. The water just crawled through it up. And when it reached the marker line, it started to blur the line a little bit at first. And then as the water continued to travel upward, it took traces of the marker ink with it. So it's kind of just like this little slow moving glacier-like bleeding of the marker color. And at least really noticeable in the first one I did, it kind of separated out the color a little bit. Like the green I picked, you could see a lot of kind of blue in it as it started to crawl up the filter. It was pretty cool.
Did it leave some yellow behind?
It did. I think the yellow was a little bit harder to see. But it definitely was both of them. It seemed like it was showing what made up the green.
So it's kind of like science and art together. Okay, so if I was asking a kid about this, I would ask these questions. Do you want me to ask you those questions, Jam?
Sure, yeah. I'll answer anything. I'm an open book.
That's good. Probably more so than most children. Why do you think water travels against gravity up a coffee filter?
Man, that's a good question. I'm going to give a blanket answer that's it's not quite as broad as saying because of science, but I was going to say because of intermolecular forces.
Ayo!
And I was thinking kind of like in other things you talked about, like different forces are stronger than other things. Like, say, the gecko crawling up a wall, the dispersion forces of the gecko that creates and uses are stronger than gravity, which is why he's able to stay on the wall rather than just fall off. So my thought would be that something about the intermolecular forces of the water crawling up the filter are just stronger enough to happen, even though gravity would really normally be trying to keep it down.
Right. So it is intermolecular forces.
Yes.
There's some molecular interaction happening there. And in the walls of a glass tube, that's called capillary reaction, where it goes up the sides like that. So I'm not sure if it technically counts here as capillary action, but the basic idea of that is right. The water crawls up the coffee filter, and it does that because it's got some molecular interaction and attraction to the filter paper. I don't really know what the filter paper is made out of or why that happens, but it does soak in up like that. Okay, next. Where do you think all those colors came from? Where did the blue and yellow come from?
Well, in the case of green, I know that blue and yellow make up green.
Mm-hmm.
And so when they make that ink or whatever it is that is in that marker, they had to use both, mix them together. So I guess for some reason it's splitting them apart.
That's right. Why do you think they spread it apart?
Could it be a similar reason to the prism kind of deal where because different colors make up the light and it breaks it apart whenever it encounters something that happens to it? I don't know. Or maybe because water like undoes something that made the things stay together. Those are my two very not perfect answers.
Okay, so those are kind of right. So a marker is made up of organic. I guess I don't know for sure if they're organic, but a marker is made up of compounds, different molecules. And those molecules will be different enough that when water comes along and moves up the towel or the filter, I was thinking a paper towel, but the coffee filter, things that are more attracted to water are going to move along with it more easily, and things that have less intermolecular forces with water are going to stay behind more. And that is a technique that we use in the chemistry lab every day.
Really?
Yes, you can do this on a very small scale with a piece of paper about the size of a matchbox. It's a special type of paper, and you can put a little drop, you don't do a whole line, of something you're studying in a chamber and watch the solvent move up and see all of the different things that made up that material separate out. So if you took a thing of coffee, maybe you could put a drop of coffee on there and then put it in some kind of solvent, and it would spread out all the different molecules that are in coffee.
Huh.
So that technique, we use that if we're running a reaction and we want to see if all of the starting materials used up. We can take a little bit from the reaction mixture, put a drop on the piece of paper, and it'll separate out, and we can see the starting material and see the final product and see what the proportions of them are.
Wow.
Or on a bigger scale, you can use chromatography to put in all the stuff you made. So say you made a reaction, you mixed A plus B, and you get mostly C, but there's also still some A and some B, and sometimes other things happen in a real reaction, and you get D, E, and F. You can take all of that material and put it in, we call it a column, but it uses the same techniques of this. It uses chromatography. It's column chromatography. And gravity will move that solvent through, and the things that dissolve more easily will come out first. And then as the lines keep coming, you'll be able to actually collect a whole group of that sample. It's kind of complicated to describe, I feel like, but basically imagine a giant coffee filter, and you can just separate out each one of those bands of color.
Wow.
So this is a real technique, a real thing that we use in the lab all the time.
Dang, that's crazy.
I
did not expect it to have such a significant place in regular experiments, I guess.
My students just did a lab on that this week.
Nice.
So that is just some of the basics of what is going on in here. Now, you're an adult man who's been learning chemistry a lot for the last year of your life and who took some classes. If you're asking a kid that, you can not look for such technical answers, and you don't even have to give them the actual thing that's happening. You can just have them describe in their own words what they see. You can have them think about where the colors come from. You can have them think about how the water moved up against gravity, and they can just say, oh, maybe it likes to stick to the rest of the coffee filter. You get them to think and talk and try to use their critical thinking skills, and don't worry too much about getting the exact technical jargon language. You can say, that's right, the water separated out the colors that made up blue or that made up green or whatever. The other thing you can do is now we've talked about the science. Let's talk about the art. What will happen if you use different colors and then try it?
Yeah.
This is an experiment. Now, what if we do a coffee filter and we alternate like blue line, green line, blue line, green line, blue line, green line. Let them try that.
Yeah.
And you can have so much fun with this, and it's such a cheap experiment.
I'm kind of smiling because Melissa hasn't watched the video of me doing the experiment yet, but
No, I haven't.
I did it with just one color, green, and then I did it with multiple colors after that. So I was curious. I was like, I gotta see what happens if I have multiple colors.
So Jam is just a big kid.
Yep. Aren't we all? Or shouldn't we all be?
You're inspired to explore your curiosity, so that's good. Some other colors or some other questions you can ask them regarding the colors is you can say, what colors do you think are going to be in this one? Name every color that's coming out of it if they're a younger kid. You can adapt this. Your child better than anyone, but you can adapt this to them to help them think through what they're seeing and what the implications of that are. And that's what I have for you today.
Awesome. That's a fun experiment.
I'm glad you liked it. I can't wait to watch the video of you, and we'll post that video online.
Yeah, I think it's a really good one too because it was really simple. It was easy for you to just tell me how to do it, and I didn't get too lost trying to. And it's so visual too, so that was kind of cool. This has been another Chemistry at Home, a little bonus bit of chemistry that you can do yourself or with your family or kids or whatever. And keep letting us know what you guys think of these and ways we can improve them. If you have any feedback for us, don't hesitate to let us know that. This episode of Chemistry for Your Life was created by Melissa Clooney and J.M. Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.